It's the end of June 2021, and I am starting to machine the first parts for the new Mark IV Rotary fly tying vise by Maine-Made Best. I'm here in the shop, and I'd like to introduce you to one of the machines that I use primarily to make all of the parts and pieces for the vise. This is a 1952 Wade model number 7 turret lathe, and before the advent of computer controlled machines, turret lathes like this were pretty ubiquitous in every production machine shop, and they are how duplicate parts were made. Wade was considered one of the best lathe makers in the United States, and they specialized in making high precision tools, lathes in particular, for people who made high precision instruments like watches or measuring tools or anything that required a very high level of precision. And as you can see, this is a very old lathe. It's 70 years old, and it was used extensively over those 70 years, and it is still in operation and highly accurate. I can turn parts to this on this lathe to a concentricity, meaning a perfect roundness, to 0.0002. So that's 2/10,000ths of an inch. That is almost imperceptible when it comes to measurement. So I'd just like to show you how the machine works, and I will show you the first part that I'm making, which is a knurled knob. And I'll try to get that in front of the camera so you can see it. You can see it. It puts a very, very nice surface finish on the part, and a very sharp and well-defined diamond knurl. Now this this part itself will then have to have subsequent operations done to it. Namely, it will have to be tapped for a 1/4-20 thread in this hole. But as you can see, there are only 6 stations on the turret, and you can't do always everything you want at the same time. So sometimes you have to do as much as you can, and then you'll go back. I'll put this diameter right here in the lathe and power tap from the other end there, and then I'll face that end to clean it up. So this is the turret right here. It moves in and out. As you can see, there is a bar feeder system. So I would get the stock that I use in a long bar, typically 6 to 12 feet, and it goes onto this gravity-fed. You can't see from this video, but you can see there's a carriage at the back which holds the end of the bar with a bearing on it so it can spin. And then this carriage is being drawn forward by these wires, which come from the carriage, come under a wheel, go up to a pulley, and then there's a counterweight which pulls down and therefore pulls the bar through the headstock. And I open and close this right here, which is called a collet, and that holds the workpiece, either loosens it or tightens it. And then by drawing back this hand lever, which is right here, the turret indexes around, and you can perform all the various functions on it. And you set the turret for depth. Each station has its own depth. And you can see the order of operations here is there's a stop for length, then there's a spot drill, then I'm drilling with a number 7 drill so that I can later tap it for 1/4-20. Then these 2 tools here are cutting tools. They cut the part to the diameter. So the first cutting tool takes a 1/4 of an inch off to leave that diameter, and then the second cutting tool cuts just a probably about 20 thousandths off here, to give a consistent diameter for the knurling. And then this tool right here is a knurling tool. And that knurling is actually a cold forming process, meaning you're actually just embossing the metal. You're actually kind of squishing it between two rollers that are harder than the material that you're squishing. And that's how you produce a diamond knurl. And those wheels are set at various angles to give you the shape of the diamond. So, and then there's a carriage here, which you can face the part, meaning you can put a nice clean finish on the face, and then this right here will cut the tool off, or cut the part off, and it'll fall off, and then you can work on your next one. And this right here is a line for coolant, which cools the cutting tool, and it floats chips away. And I have that set up connected to a foot pedal so that I can turn it on and off at will with a foot pedal. So what I'll do is I'll move the camera, and then I will show you how the operation works. So I've got the machine ready to go, and so basically what you're going to see is start to finish. We will set the workpiece against a stop to regulate depth. Then we'll go in spot drill. Then I'm going to go in pre-drill or drill the hole required for a 1/4 tap to come in and tap afterwards. Then I'm going to cut the 2 diameters. Then I'm going to knurl, and when I start to knurl, there has to be a speed change. I have to slow the machine down, and there's a set of levers right where this hand is, which I can automatically on the fly put it in forward or reverse, and then fast or slow. And that's because different operations require different speeds, and also sometimes you have to reverse the machine, like when you're power tapping to get the tap to come out again. So I will start like this. I'm going to open the collet, and by collet I mean something like this, which is sort of a spring. It closes by being drawn against this taper, and then when you push it out a little bit, it releases, so the workpiece can slide through, so you can actually move the workpiece without shutting the machine off. So I'm going to power up the machine. I'm going to first go into high speed. I'm going to open the collet closer. Now my bar feeder has pushed the work forward. I'm going to push the depth stop against the depth stop on the turret, close the collet, and now the workpiece is held. I'm going to index, foot pedal on the coolant, spot drill, number 7 drill, then I'm going to go to my diameters, move my coolant a little bit. Now this pass is taking off 1/4 of an inch, so I'm going to go quite slow so the surface finish is good. You don't want to force the machine or rush through the operations. You have to be gentle and pretty conscious of what you're doing. Now I'm going to go to my 2nd diameter. Now I'm going to knurl, so I'm going to go into a slow speed. Back to high speed. I'm going to clean the knurl up with a toothbrush, one that I don't use at night. Now I'm going to face. Now I'm going to cut the part off. Here's the part. Now we're going to go repeat the process. And that's how you make a knurled knob.